Now, way back in 2005, we went from non-condensing boilers to condensing boilers, and it's helped to reduce the carbon emissions of the UK. But what is this condensing boiler, and what was the difference between condensing and non-condensing boilers? Well, this is what this video is hopefully going to tell us, and it's also hopefully going to show us how we get rid of this condensate which condensing boilers make. Now, back in 2010 and again in 2018, when we had the beast from the east, the temperatures in the UK dropped to around about minus 18 degrees in some places. Now, this caused a lot of problems for our condensing boilers, where the drains were installed on the outside of the building. So this resulted in significant call-outs for gas engineers for boilers which were broken. To combat this, the HHIC, or the Heating and Hot Waters Industry Council, the building regulations, the British standards and the manufacturer's instructions have released information to hopefully help gas engineers combat this condensate pipe from freezing and hopefully reduce the risk of it. So, what is this condensate and condensate pipe then? The main function of this condensate pipe is to take this acidic water, which is from the combustion process of the boiler, safely away from the property via the internal drain system and then onto the sewer. So this condensate is produced when the boiler is burning natural gas. So the byproduct of burning natural gas is carbon dioxide and water vapour. So what happens is, because these boilers are efficient, the products of combustion exiting the flue are lower than the dew point of the water. So it turns that water vapour back into a liquid, which we need to get rid of. And because of the condensate being part of the combustion process, it becomes acidic, which is about the acidity of tomato juice. A typical hour-long running of a condensing boiler will make about 2 or 3 litres of condensate. That all depends on the kilowatt rating of the boiler. A 24 kilowatt would probably make 2 litres, where a 30 kilowatt would probably make 3 litres. But the boiler, what it does is, instead of trickling out this condensate, which they used to do when they first came out, and that was causing massive problems with freezing, they kind of dump about 300 millilitres of water in one go through a siphon, and that also helps the condensate pipe not freezing. So this 2 or 3 litres of condensate can actually make about 1200 litres of water a year. This is one of the kind of first condensate traps what came out from Ideal. So this is from an Ideal ICOS, and this is one off a first gen Logic, and you can tell that because it has a removable bit on the bottom here, which isn't on the new version. So this is kind of evolved as well. So that's how they've changed. That's one of the first ones to this one now, and these now have to have a 75mm trap in there to help all this getting rid of the condensate and to stop smells and products of waste getting back into the boiler. But when it comes to having this condensate pipe installed, there are certain criteria the gas engineer needs to follow to make sure it complies with 1, the building regulations, 2, the British standards, but most importantly, number 3, the boiler manufacturer's instructions. The minimum size we can use for this condensate is overflow pipe, or 21.5mm OD or 19mm pipe ID, but we can only run that for a maximum of 3 metres internally, and we cannot run it externally at all now. External condensate pipes need to be a minimum of 32mm, and again only run for 3 metres, but they have to be insulated with type 0 insulation according to the building regulations. But what material can we have this condensate pipe made of? Well, I've said it's got to be plastic, and we use overflow pipe internally, and it has to be standard waste pipe could be outside. We cannot use copper pipe and we cannot use steel pipe for a condensing pipe because it completely rots away. Now, this is what happens to copper pipe when you use it as a condensate pipe. Can you see that? My very good friends Ben Green and Paul Cherry brought me this last week, and they gave me the inspiration to make this video because this is not very good, is it? So that's why we can't use copper, because it just corrodes it. And yes, this was on a boiler condensate pipe, and why did the customer not notice that? We can use polyvinyl chloride or PVC. We can use unplasticized polyvinyl chloride or PVCU. We can use polypropylene or PP. We can use chlorinated polyvinyl chloride or PVCC. And finally, we can use ABS. There is no way I am going to say what ABS is. I'm going to put it here. So this is the proper name for ABS. Can you say it? Because I can't. Now, because this condensate drain is working under gravity, they have to have a minimum fall. Now there's two sizes you'll see banding around for the minimum fall. The one for most of the manufacturer's instructions for the boilers is 45mm per metre, but the building regs say 52mm per metre, so you can kind of use both of those. Now this is what we mean by it. So the blue line you can see here is the centre of the pipe. So you can see from this section here, we've drawn a parallel line straight with our 1 metre. And you can see from that straight line to the centre of the pipe is our fall. So either 52mm per metre or 45mm per metre. So hopefully that helps with what we mean by the fall. So it's from centre to centre within 1 metre. And the clipping distances need to be no more than 0.5 metres or 500mm horizontal or 1 metre vertical. But if you've got a flexible connection, that has to be clipped every 300mm. So those are, to the British standard, 6798. When a gas engineer is replacing a boiler or doing a brand new install, the considerations for the condensate pipe need to be really looked at. And the main thing we need to do is try and install this condensate pipe internally and run it to an internal soil stack, which is the preferred method. But they can be run into internal waste systems such as waste coming from kitchen sinks, wash basins, baths or even shower trays. But these wastes going from internal systems have to be a minimum of 32mm in diameter. And any waste pipe connected to a condensing boiler has to be, if it's outside, insulated with UV rated insulation with a minimum wall thickness of 19mm. It also needs to be terminated below the grid, but above the water level, and cut to a 45-degree angle and have a leaf and debris guard over the top of it now. And this is all to stop the chilling process, so freezing cold wind chill factor wind blowing across the top of the grid and freezing the outlets of the drain. So even when an engineer goes out to service or repair a boiler, they should be looking at the way the condensing pipe has been run. And if it is run outside and it's done in just overflow pipe, or it's done in 32 waste pipe and it's not insulated, then the engineer has the responsibility to inform the responsible person that the condensate pipe is not to current regulations and should be upgraded. No, it should be upgraded. You don't need to pin them down on the floor and tell them that you've got to have it done. No, you've just got to kind of inform him it must be done. What if we're connecting into a soil stack or a rainwater pipe? We'll take the soil stack first. Obviously, what have you got going down a soil stack? Could be a bit smelly. So what we have to do, as you can see here, we have to put a 75mm trap into the waste pipe, the 32mm pipe coming off the soil stack. If the trap within the boiler isn't more than 75mm, then we have to put an air brake in there so we don't get the mess going into the boiler. I've seen a couple of boilers where the mess has got inside. It's not nice. If we're connecting to a rainwater pipe, we definitely need to do an air brake outside. And this is important because if it gets blocked up down at the bottom or it gets frozen, then you could get all that water then just going straight into the boiler. And again, I've seen a couple of boilers where they're filled up right to the top in the combustion chamber with water, where it's been connected to a downpipe or a rainwater pipe. What if we haven't got a waste pipe within 3 meters of the boiler and there isn't anything external neither? Well, we can use one of these. So this is a condensate pump. So what happens is the boiler condensate pipe goes into there. When it gets to a certain level, a little pump inside here is activated and pumps it out to drain via this little plastic pipe. Couple of things with this though is it has to be interlocked with your boiler. So if anything happens to this, it stops your boiler working, because otherwise you get all this condensate pouring out all over the place. So these are also very good if you're in places such as a basement, the boiler's in a basement, or you've got a basement flat, something like that, where the boiler is actually lower than the drain system. So you can actually use this then to pump it higher up, because it does go quite a distance up. Always check your manufacturer's instructions though for your maximum lengths. And always check your boiler manufacturer's instructions how you're going to interlock it into your boiler to stop it working. Well, the boiler stopped the boiler working if this stops working. There are also some purpose-made condensate pumps where you can actually put your discharge pipe into them also. But you can't just use any condensate pump, you've got to use a specialised one, which will take the temperature of your discharge water also. Another way you can do it is a soakaway. This soakaway, what is it? Well, the name's pretty self-explanatory really. What we're doing is we're using the ground to soak away the condensate. So the way we do this is by the use of limestone chippings, and what this limestone does is it neutralises the acidic water and allows it just to go into the ground and cause no harm to any plants or animals basically. But one of the things we've got to do is be very aware that this acidic water can corrode and disintegrate cement. So we need to make sure we follow the measurements behind me here to make sure we don't let the wall fall down. The first one you can see here is how far it needs to be away from the house. It needs to be a minimum of 500mm away from the house. And you can see it's 32mm insulated going through the cavity wall. It then runs down into the drain itself. So our hole is 400mm deep, but our actual purpose-made soakaway tube is 300mm minimum in length. And the holes there are evenly spaced of 25mm apart in all directions, but at least 50mm off the bottom. And you will put that at the front of the tube, so it's directing the condensate away from the house. But remember, when you're servicing a boiler where it's got limestone chippings, you need to check the limestone chippings every year to make sure they've not all disappeared, because otherwise you're just going to be putting acidic water back into the ground. Now, it's becoming pretty common now that engineers are installing their condensate pipe with pressure relief valve in the same system. Instead of taking the pressure relief valve outside, they're discharging it into the same pipe. And BS6798 doesn't really say much about it. It just basically says there's two ways of doing it. There's one way which is actually done by the manufacturers inside the boiler, and I know Wiesmann do this where they combine the blow off and the condensate inside the boiler. I can't think of any other manufacturers that do it, but if you do know them, put them down at the bottom in the comments. And the other way is to do it externally, and BS6798 says refer to the manufacturer's instructions of the boiler to see whether they allow you to join in the blow off and the condensate. And again, I can't remember seeing that anywhere in the manufacturer's instructions for the boiler. But if you do it, just bear in mind of the flow rate of the pressure relief valve compared to the condensate pipe and the temperatures. So your condensate water is going to be a lot less than the 100 degrees your blow off could be doing. And there are a couple of manufacturers who make special ton dishes for the blow offs. So Tesla and Hotton. And again, refer to the manufacturer's instructions for the ton dish air brake and follow them to see how you would connect them in. But I always, if I'm doing it, connect it in this way where I'm using waste pipe rather than, which I've seen quite often, the actual condensate pipe where they've connected the discharge, the blow off into the condensate pipe. But British standards don't say much on it, and neither do the building regs. It all says refer to the manufacturer's instructions. Now let's talk about this insulation which I mentioned at the beginning of this video. Now a lot of engineers use this Classo nitrile rubber insulation, I think that's how you say it, but there's a couple of problems with that. First of all, it's not UV protected. So second, you've got to protect it, and you've got to use like a special paint to paint on it, and you have to do it twice within a few weeks. You have to follow the manufacturer's instructions with it, but it stops then the rubber cracking and turning to dust basically. But there is another product on the market which I've actually done a full installation video because they sent it me for free ages ago, and that is this stuff. So this is from Condensate Pro, and it's designed to go over 32mm solvent weld. You can also get it for your 21.5 if you want. But yeah, I've done a full installation video on this, shows you exactly how to do it. And the good thing about this stuff is, even though you can actually get some paint to paint it, you don't need to keep painting it. You only need to paint it when it's looking a bit tatty. So this is the no-brainer really for engineers if you want to insulate your condensate pipe which runs outside. It's all sorted out for you. It's a little bit expensive, but you've got to comply with the regulations now, and this certainly does comply with the regulations. So again guys, it's a no-brainer. So if we need to insulate it, you can use the Class 0, the rubber stuff, but you've got to protect it from UV, or you can use this stuff. There are other products on the market. You can use tray seating, but tray seating still needs lagging on it. So you could put tray seating inside this. Worcester also years ago produced this condensate, I can't remember what it's called now, some kind of condensate bottle which clips onto your flow pipe of your boiler, and they say you don't need to insulate your pipework then because the flow pipe actually warms up your condensate and it dumps about 500 millilitres of water in one go. But I don't know whether that still complies or whether they actually still sell it. I need to have a look at that, don't I? But if you know you can still use it, if you're from Worcester and you know you can still use it, put it in the comments below and tell me exactly if it can be used or not, because I can't find any new stuff on it to say it can or it can. And that's the end of this video on condensed pipes. Thanks for listening, thanks for watching, and I hope this video's helped you to understand the new regulations about insulating condensate pipes. So cheers guys, and I'll catch you on the next one.